Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. Remember, this thing here means this 2 bracket n factorial as opposed to 2n brackets factorial. Okay, so this means this. So you've got to do this first and then times 2. Well, press pause and have a go. Okay, try and understand what's going on here. So here you've got what the at the top, imagine it to be 4 times 3 times 2 times 1, and then at the bottom it will be 4 times 3 times 2 times 1, and then you've got it times 2 here. So you could just cancel these out. You could just bear that in mind. Okay. Well, anyway, let's try and evaluate this now. So the trick to doing this is to factorize the n factorial. So rewrite this as this, because if you multiply this out, this times this times this, it will give you this thing here, and then factorize the n factorial out. Factorize it out. This will then become this. So if you multiply this times this times this, it will then give you this. So factorize out the n factorial. And then you can see that, well, if you think about it, imagine n to be 4. 4 times 3 times 2 times 1 divided by exactly the same thing here. So you do have the right to just cancel these two out. So you do have the right to do that. And then as n tends to infinity, this is a lot bigger. It's going to be a lot bigger than n squared. So this is going to head towards 0 as n tends as n tends to infinity. This thing here is going to head towards 0. So 1 plus 0. This thing here is going to be 1. So this thing here, you see, as n tends to infinity, n factorial here will be a lot bigger than n. So this thing here is going to head towards 2. So well, from here, cancel these two out. That will then give you this, and then you can see that this is going to head towards 0. This is going to head towards 0. So it really boils down to the limit of a half. A limit of a constant is really a half. So the answer is a half. So next question. So find the limit of this as n tends to infinity. Whenever you see this n factorial, whenever you see n factorial versus 3 factorial, if you can't remember which one's going to get bigger, which one's bigger as n tends to infinity, then imagine this to be, I don't know, 3. Let's say n equals 4. So it's going to be 3 to the power 4, which is 3 times 3 times 3 times 3, and then for this one here, it's going to be 1, 2, 3, 4. Let's extend n. So here you've got a 3 times 3 and so on, and then here you've got 5, 6, 7, 8, 9. So you can see that that from alright, granted from here to here, this is going to be a lot less, but then beyond here, as n tends to infinity, you can see that n factorial here will be a lot bigger than n. Well, that's just a side note, and we've done this many times. You should by now know that this will be a lot bigger than this. Well, anyway, find the limit of this as n tends to infinity. Press pause and have a go. Okay, so to do this, factorize n factorial. So rewrite this whole thing here as this, and then this one here, rewrite this. This is just a trick. So you would factorize out the m, rewrite it as this, because if you were to multiply this out, and this whole thing here would be the same as this. So these two are exactly the same, but just written differently. So now, if you look at this, as n tends to infinity, n factorial being a lot bigger than this whole thing here is going to head towards 0. So this whole thing here is going to be 1, and then as n tends to infinity, this thing here is going to head towards 0. This is going to be 1. So it's really, this is going to go to 1. This is going to go to 1. So you've got this. Well, you can see that this here, well, n factorial imagine it to be 4 times 3 times 2 times 1, and then you divide it by just the n, 4. So in a way you can cancel this out. So in a way you can think of it as being n minus 1 factorial. But the thing is, looking at this, you can tell that it's heading towards infinity, because this is going to be a lot bigger than this. Okay, yeah. So the limit is well, it diverges. The sequence diverges. Okay.